Section 11.1 Conic sections, parabolas. Depending on the way we cut cones, we get different conic sections. If we cut the cones horizontally, we get a circle. If we cut it with an angle such that the resulting section is closed, we get an ellipse. If we cut it with an angle such that the resulting section is open, we get a parabola. And if we cut it vertically, we get a hyperbola. A parabola is a set of all points in the plane that are equidistant from a fixed point F called the focus and a fixed line L called the directrix. The vertex V of the parabola lies halfway between the focus and the directrix, and the axis of symmetry is a line that runs through the focus perpendicular to the line of directrix. Suppose the parabola is of the form x minus h squared equals 4p y minus k. The vertex is at h comma k and the directrix is y equals k minus p. Focus is at h comma k plus p, and if p is positive, parabola opens up, and if it is negative, parabola opens down. On the other hand, if the parabola is of the form y minus k squared equals 4px minus h, the vertex is still at h comma k, the directrix is x equals h minus p, and the focus is h plus p comma k. If p is positive, parabola opens right, and if p is negative, parabola opens left. In this example, we're asked to find the equation of the parabola given its vertex and focus, and then graph it. Focus is 2 units up from the vertex, so p equals 2 and the parabola opens up. By using the formula x minus h squared equals 4py minus k, we get x minus 0 squared equals 4 times 2 times y minus 0, which simplifies to x squared equals 8y. Line of directrix is y equals negative 2, vertex is at 0, 0, and focus is at 0, comma 2. So the parabola opens up as seen in the graph. In this example, we are asked to find focus, directrix, and graph y equal negative x squared. Y equal negative x squared can be written as x squared equals negative y. And so the vertex is at 0, 0. 4p equals negative 1 implies that p equals negative 1/4, which means that the parabola opens down. And the focus is 1/4 of a unit down from the vertex at 0, negative 1/4. And directrix is y equals 1/4. And the graph represents a parabola opening down with the vertex at 0, 0. Here's another example to find focus, directrix, and graph the parabola given its equation. We first simplify the equation to y squared equals negative 6x, so the vertex is at 0, 0, and 4p equals negative 6 implies that p equals negative 3/2. So parabola opens left and the focus is 3/2 of a unit to the left of the vertex at negative 3/2, 0. And directrix is x equals 3/2, and this is the graph of the parabola. Here is another example to find the equation of 4 different parabolas with vertex at 0, 0 and 4 different focus points. For all the focus points, the y-coordinate of the vertex is changed. Thus, the parabolas open sideways. For f1, the equation is y minus 0 squared equals 4 times 1/8 times x minus 0, which simplifies to y squared equals 1/2 x. For f2, the equation simplifies to y squared equals 2x. And we can see that for f3 and f4, equations simplify to y squared equals 4x and y squared equals 16x. Parabolas have an important property that makes them useful as reflectors for lamps and telescopes. Light from a source placed at the focus of a surface with parabolic cross-section will be reflected in such a way that it travels parallel to the axis of parabola. Conversely, light approaching the reflector in rays parallel to its axis of symmetry is concentrated to the focus. In this example, we want to find the vertex, focus, directrix, axis of symmetry, and graph the parabola. First, we separate x variables from y variables. Then we pull out the leading coefficient of the squared variable and divide both sides by it. Now we want to complete this square and simplify the equation to get y plus 1 squared equals 1/2 x plus 4. This follows one of the forms, so vertex is at -1, 4, -1, and 4p equals 1/2 implies p equals 1/8. Since y is squared and p is positive, parabola opens right, with the focus at -31/8, -1. Directrix is x equals -33/8, and axis of symmetry is y equals -1. Using these information that we just found, we graph the equation of the parabola. In this example, we want to find the equation given vertex and directrix. Using directrix and k, we can find p as k minus directrix, that is, p equals 5. So we use x minus h squared equals 4py minus k and vertex and p to find the equation as x minus 5 squared equals 20 times y plus 3. These are the suggested textbook homework problems and required ALEKS homework for section 11.1.